Recording, 3, 2, 1, test. What's up, Mr. Strange? I'm gonna show you a video with the energy. So, the energies that I chose for this one, I chose gravitational potential energy, and I also chose kinetic energy. So those are gonna be my that's what I'm going to be talking about and the transfer between it. So let's just a little reminder. So to abbreviate it, I put GP for gravitational potential energy, and for kinetic it is being transferred to kinetic energy, right? And the example to kind of represent this in the best way that I believe is a roller coaster. So I'm going to draw you a little roller coaster right here. So I have a roller coaster. I'm just drawing a random roller coaster just to give a little explanation on how this works. So I have a cart. Let's see. So I have a cart right here. And when there is enough work being done, it is being transferred to gravitational potential energy. And once the cart reaches the highest point at the top, let's say right there, there is zero. Let's see what blue marker is. There is zero kinetic energy. There's zero kinetic energy because that's where the max of gravitational potential energy there is. So once there's zero gravitational kinetic energy, that is because there is a max of GP, gravitational potential energy at this point. And so as the car speeds up, let's say to this point, when the car speeds up to that point, gravitational potential energy is transferred back to kinetic energy. So once it is coming down, it is being transferred back to kinetic energy. Now, let's say when the cart's at this point, for example, yes, there is potential energy, but it is more than just potential energy. It's more than just potential energy, it is gravitational potential energy. This is because there's potential energy at this point, but there's gravity being involved. That is because gravity is bringing the cart down. So when gravity is bringing it down, we call that, we call it gravitational potential energy. So now I explained to you, once the cart comes down, then it is going back to kinetic energy. Now, let's say, for example, to solve for both gravitational potential energy and kinetic energy, I'm going to give you the formula. We use joules to calculate energy. So to calculate gravitational potential energy, we do GPE. To find its gravitational potential energy, we use M, mass, times gravity, 9.8 meters per second, times its height. Most problems would give us both the mass and the height. To find kinetic energy, we do KE. We do that. We do 1/2 times its mass, and times velocity squared. So these are the popular formulas to solve this. So I also wrote a little description here to little memorize. The further the object falls, the less gravitational potential energy it has and the more kinetic energy it has. And this is a perfect example for the roller coaster. There were more examples that I could have chose from for this topic. I could have chose a bouncy ball, for example, or like a marker. There's gravitational potential energy here, but as soon as I drop it, it is going back to kinetic energy. So I have a little problem to solve this. So let's say we have a problem with a cannonball has a mass, let's say has a mass of 40 kilograms. Let's say that it has a height of 3 meters. And they want us to find its gravitational potential energy. So all we do is we just plug in the numbers into our formula. So we do 40 times gravity, which we should all know, 9.8 meters per second, times its height. So its height is 3. Now I already calculated that because I came up with this problem. Hopefully, it is equal to 1,200 joules. I believe that's how you spell joules. I may be wrong, but I think that's right. So we found that. Now we found that, and it continues on, and it tells us to find its kinetic energy. So for this, we just do. Let me get a different marker to show you. We do PE is equal to kinetic energy. So we already know it's gravitational potential energy, so we just plug in the numbers. We go 1,200 is equal to 1/2 times mass. So we already know it's mass, so it's 40. It is 40 times its velocity. You don't know the velocity yet, so you just leave that like that. And then from there, so to find velocity, we do velocity is equal, and since this time is square, we square root that. So we do, now we do this, we divide it. Now we do times 2 because we try to cancel out the 1/2 right here. So 1,200 joules, and then divided by its mass, so 40. And if we calculate that, it gives us 7.7 meters per second. That is velocity. That is kinetic energy. So there's not a lot of hard work or a lot of work that needs to be put in. All you just need to know is, given its mass and its height, to find gravitational, you just plug that in, multiplied times gravity. And I showed you the basic steps on how to solve for its velocity. There's not a lot to it. There's not a lot to it on explaining. I think this is pretty simple. Hopefully I did a good job on explaining the transfer between these two energies. I think I did. Let me see. A little more on the roller coaster. So before it gets to this point right here, it starts losing kinetic energy, and once it starts losing kinetic energy once it's getting higher, so we start losing kinetic energy. But then once we start losing kinetic energy, we start to gain gravitational potential energy. Now, I mean, these are little basic little descriptions on the transfer between these energies. I hope I did a good job. This little description. It's a little easier. The further the object falls, the less gravitational potential energy it has, and the more kinetic energy it has. These are the basic formulas to solve for these two types of energy. Little title right here. Yeah, so this being transferred to gravitational potential energy to kinetic and transferred back. So I guess the roller coaster is probably the best option. And again, there was more options to choose from, like a bouncy ball, a pendulum. I think was also a good option. But I hope they did a good job. Thank you, Mr. Strange.